Hello folks, I'm back again. I'm gonna go over today some just one example related to integration by parts just as a start. So I'm gonna continue with my videos related to calculus or any other math courses. So the main one of the main concepts in integration by parts, and let me just first write down the formula. So if we have u dv, we just can write it as uv minus integral v du. So this fact basically comes from the actual product rule in differentiation, and then that leads us to this solution, this formula. And I can say this is a beautiful method in integration. The idea is this: you have a first integral u dv, which is something that cannot be integrated directly by the methods that we have, like basic substitution or regular direct integration. It doesn't work. But you rewrite it and v du becomes something integrable, and once you know how to integrate v du, then basically you solve the problem because you know what u and v are. So the method that I'm going to talk about, like only for this example, these type of examples. So my example is this: the integral of x plus 5 times cosine x dx. So this is one of the main type of examples, integration by parts. So I'm going to write here down, can really put that note here. If you have an integral of a polynomial multiplied by a function like cosine x, or it can be sine x dx, then the selection will be u will be your polynomial and dv will be the other function, the trig function cosine x or sine x dx basically. So the reason is, I can say this, really, if you whatever you choose for dv should be something that you can integrate easily. Here the polynomial can be integrated easily as well, but the problem will be this: once you rewrite it with the form v du, then the integral will become more complicated, because the polynomials, you see, if you integrate it, the degree is increasing. If you take the derivative, then the degree goes down. So that's why choosing u to be the polynomial, at every step that you're gonna be decreasing the degree of the polynomial by 1 for the next integral. I'm going to show over this example. So if that was, for example, and you should apply the integration by parts as many as the number of degree that you have for the polynomial u. So if that was an x squared, then you apply twice. If it's x cubed, then you apply 3 times, and so on. I'm going to give different type of examples, but for this specific type, this is the way. If this cosine x, sine x, or we can even write here the function e to the x as well. If you have e to the x, the same method will apply. But if you have a logarithm function, then it will change, and as I said, I can give you like different examples in different videos. But for this one, so you know, we just said u to be x plus 5 and dv will be cosine x dx. So, and be careful, the thing is this, really, this is something that I'm giving you here, but you don't really have to memorize. The reason is this: if you have only 2 options in this case. If you make the wrong choice, then you're going to see that immediately in the next step, because if you choose dv to be x plus 5, then the integral will be x squared over 2 plus 5x, which will make your integral on the right side more complicated, and that's where you stop, because it should make it something easier to integrate on the right side, or just going towards something easier. So here, if you write it, which is uv minus integral v du, so uv will be, you see, and of course here I'm going to find du will be basically dx, and then v will be sine x. You see, for this one I'm basically integrating, and for this part to get du, you take the derivative. You see, it's really that simple. You take the derivative, the antiderivative of cosine x is sine x. So now I write uv minus v du, which is x plus 5 times v is sine x, then minus integral v du, so v is sine x, and then dv, and du is dx. You see now this integral is something, this is integrable. We know the antiderivative of sine x. If that was an x squared plus 5, then we're going to apply it again until we get something that we can integrate easily. So if I find the antiderivative of sine x, I got x plus 5 sine x from here. Then I got minus, you know, the antiderivative of sine x is negative cosine x. And I got a plus c. So if I simplify, that becomes x plus 5 times sine x plus cosine x plus the integral constant c. And I hope this is clear. I'm assuming this is something really simple. It's not that complicated. So this is the main example to start with. You can try the ones with something, some polynomial of degree 1 with cosine x, sine x, or e to the x. You can try it yourself, because math is really about practicing. And once you get that, then I can get like more complicated examples in the coming videos. And if you have any questions, we can write under the comments. I mean, I can try my best to answer. And if you want me to solve examples on specific content, then you can again write it on the comments as well. So thanks for watching. Bye.